Okay, today is Chapter 5, Section 2, Systems of Linear Equations and 3 Variables. So, just a forewarning, I am not feeling well today, and I'm having to record this at home. So, I have also a very, very noisy, needy cat, and if you happen to hear him, it's because I'm not in my office. Actually, let's go ahead and put. Yeah, let's go and put this on the front page here. Alrighty. So, systems of linear equations and 3 variables. So, up until now, we have had, 2 equations realistically, right? 2 equations, and I've told you that. Well, let's actually talk about the compounding interest, right? Compounding interest has 5 unknowns. So when we have 5 unknowns, in order to solve, I have to know 4 of those 5 unknowns, and then I can solve for that 5th one. A system of linear equations and 3 variables, we're going to have 3 separate equations with 3 unknowns. And we're not going to necessarily know what each unknown is, so we're going to have to manipulate each and every single equation to figure out what one variable's value is, and then use that to find the second variable's value, and then use that to find the third variable's value. So it is a little tedious. There's some puzzle pieces you need to put together, but just a broad thinking platform here is that I have to narrow down my 3 equations into one equation and get that one unknown. All right. Again, it's kind of like making a peanut butter and jelly sandwich. You don't think of the steps. You just know what you have to do. Okay. So let's go ahead and actually look at an example and try to get an idea of what we have to do. Okay. Well, the first thing we're going to do is we're going to show that the ordered triple -1, 2, and -2 is a solution of the system. Now, in order to figure out the solution of a system, it's kind of the same way as we did before, figuring out that a value solves an equation. So something like this: if we had f of x is equal to, well, no, not f of x. Let's try it again. If we had 13 is equal to x squared plus 4, okay? And let's say that we are asked to, we are asked to show that the point, the ordered pair, well, I guess it's a pair, I don't know. Well, oh, shoot, okay. Let's put a y in there. Plus y plus 3. Okay, we were asked to show that the ordered pair 3, 1 was a solution to the equation written in white. Well, that is indeed true, right? Because 3 squared is 9. 3 squared is 9. 9 plus 1 plus 3, well, that is indeed equal to 13. So the ordered pair 3, 1 is indeed a solution to that equation. So what we're going to have to do here now is we're going to show that this ordered triple. Now, an ordered pair, as we know, is a point on a Cartesian coordinate plane. Up here we have an ordered triple. Now this could be, and more than likely is a 3-dimensional plane. Right, but let's not mess with that now. But a 3-dimensional plane, essentially, right? We have the x and y, and then we also have the vertical axis. But anyways, so we need to show that this is indeed true. So how do we show that it's true? Well, we need to plug those values in. So let's go ahead and plug them in, and let's go ahead and let's do this. X is equal to a -1. A y is equal to a +2. And then a z, the z-axis, right? The z is a -2. And all I did was basically just rewrite this ordered triple right there. All right, so what I'm going to do is I'm going to plug these values, -1, 2, and -2, into my equation. all three of them. And I'm going to make sure that those 3 points do indeed satisfy that equation. So let's start. We'll say -1 plus 2 times a y, which is a 2, minus 3 times a z, which is a -2. And is that equal to a -2? I'm sorry, is that equal to a 9? Sorry. All right. So again, all I did was I'm looking at this equation right here, and I substituted a -1 for x, a +2 for y, and a -2 for z. Well, let's do the arithmetic here. Well, we have a -1 plus 4 plus 6 is equal to 9. That is indeed a true statement. Okay, because 4 plus 6 is 10, minus 1 is 9. So that is true. Let's see if we can fit all this real quick. Might have to write a little bit smaller. Let's actually move this up just a tad. Let's put a little bit more. There we go. All right, so try this now again with the second equation. So it's going to be 2 times x, which is a -1, minus y, so minus a y, which is a 2, and then plus 2z, which is a plus 2 times z, which is a -2. That's equal to, try to remain consistent here, 9 there, and this is equal to a -8. Okay, so let's do the arithmetic here. So 2 times a -1 is a -2, minus 2, minus 4, so -2 minus 2 minus 4, that is indeed equal to a -8. Okay, so that is a true statement. And then lastly, let's move my toolbar up a little bit. And then the last equation we have is a -x, so we're going to have a -x. So this could be a little tricky. Keep in mind that we have to account for all of our negatives here. So if we have a -x, we have let's go and put the negative from the equation here, and then a -x. So that's the negative, and then x is a -1. Okay, so again, the negative here is from the original equation, right? And we have to account for it, and then x is a -1, so it's a -1. And then we have a plus 3 times a y, which is a +2, and then minus 4 times z, which is a -2, and that is equal to a 15. So let's do the arithmetic again. A -1 is a +1, plus 6, and then plus 8. Right? -4 times -2 is +8, and that is indeed equal to 15. So what we found out was, yes, this point is indeed a solution, that this ordered triple is indeed a solution to this linear system of linear equations here. Right. Now that's just to check your work. How do we get to that point? How do we get to the point where we actually know what the solution is? In this particular case, the solution being -1 to -2. Well, I've very bad news for you. It's a process. Okay, so let's just kind of go over the steps. But again, knowing the steps is important, and once you understand, you don't really have to reference. Okay. So the first thing we're going to do, when we solve a linear system in 3 variables by eliminating variables, we need to reduce the system to 2 equations and 2 variables. This is usually accomplished by taking 2 different pairs of equations and using the addition method to eliminate the same variable from both pairs. Number 2, solve the resulting system of 2 equations into 2 variables using addition or substitution. The result is an equation in 1 variable. So we're going from 3 variables to 2 variables to 1 variable, and then we get that value of that 1 variable. And then what we're going to do is we're going to take that 1 variable and plug it back into one of the equations with 2 variables. So if an equation has 2 variables and we plug in a value for 1 variable, then we can figure out what the value of the other variable is And then that's basically the method here. Right? And again, those are all words. It's all hand wavy. Let's actually do an example. Okay. So again, here we have a system of linear equations. We have we have three unknowns, and therefore we need to have three equations. All right. If we don't know the value of any of the variables, we have to have three equations. So the first thing we're going to do is we're going to have to eliminate a variable. Okay, so how do we eliminate a variable? Well, I'm going to look at all three of these equations, and I'm going to say, okay, so what I'm looking for are coefficients that I can cancel out. Right. So for instance, a 5 and a 3, I mean, I'd have to multiply this 5 by 3, and this 3 by 5 to get to 15, and this by 3, this -2 by 3, this 3 by 2, or I can do the 4. It doesn't really matter what I do, okay? I just have to eliminate a variable. So what I'm going to do is I'm going to take equation 1 and equation 2. I'm just looking at equation 1 and equation 2. So let's put EQ1 for equation 1. That is a 5x minus 2y minus 4 is equal to 3. Right? Now, let's move this off to the side a little bit. Move it to the right. Okay. So next up, we're going to do is I want to eliminate that 4z, which I did not write there. Let's fix that. 4z. I want to eliminate that z. Okay. So what I'm going to do is I'm going to take 2 times equation 2. So I'm just going to do some mental math here. We're just going to multiply the second equation by 2. So this 3x, where's my here? This 3x turns to a 6x, this 3y turns to a 6y, this 2z turns to a 4z, and this -3 turns to a -6. All right, I'm just multiplying the second equation by 2. So I'm going to have a 6x plus 6y plus 4z, and that's equal to a -6. And at this point, now I'm just going to do some arithmetic. I'm just going to, all this is over one another. I'm just going to do the arithmetic just straight on down, right? Just straight on down. So 5x plus 6y, 5x plus 6x is equal to 11x. A -2y plus 6y is equal to a 4y. A -4z plus 4z, well, that is exactly what I want. I want to cancel that. I'm trying to cancel the z here. And then a +3 and a -6 is a -3. Okay, so why did I want to cancel the z? Well, hang tight, and we'll see more here in a moment. Okay, so that was equation 1 and equation 2. So now let's do. I'm trying to reduce these 3 equations out to 2 equations. So now what I'm going to do is I'm going to look at equation. Let's see, what am I? Oh, we're trying to get rid of z. Okay, so we're going to look at equation 2 and equation 3. Okay, we want to get rid of the z still. All right, so let's go ahead and we're going to write. So if I want to get rid of the z. Okay, since I got rid of the z in equation 1 and equation 2, and I'm going to get rid of the z for equation 2 and equation 3. Now, again, the whole point of this is I'm going to get rid of the z, and then I'm going to have 2 equations with 2 variables. This variable has this equation has an x and a y, and then between equation 2 and equation 3, when I get rid of the z, I'll have an x and a y. Anyways, so I need to multiply the top one, it looks like, by -3. So I'm going to say -3 times equation 2. Okay, so that's going to be a -9x minus 9y minus 6z, minus 6z, that's equal to a 9. Okay, so that is a -3 times equation 2, and it looks like if I want to get rid of the z in between these equations, I need to multiply this second equation, this third equation, by 2 to get a +6z, so I can cancel out the z's. So 2 times equation 3, well, that's going to be a negative 4x plus 10y plus 6z, and that's going to be equal to a 6. And then I'm going to do the, I'm going to add them together. Okay, so a negative 9x and a negative 4y, I'm sorry, I keep saying that. Negative 9x and negative 4x is equal to a negative 13x. And then a negative 9y and a positive 10y is equal to just simply a y. Again, the whole point of this is to get rid of my z's. And that is equal to 15. Okay. So now I have two equations that I'm looking at here. This equation, that's not doing green, so in yellow. This equation and this equation, right? And now the whole point of this is we're going to eliminate. It looks like we'll probably just eliminate y. We're going to eliminate the y, and therefore we'll have our x value. And then once we have our x value, we can substitute it in one of the two equations I have circled in yellow there, and then I'll have the y value. And then I'll have the x value and the y value, and then I can plug it into one of the original 3 equations, and then I'll have the z value. Okay, so see how we are kind of breaking this down and then building it back up. So 11x plus 4. Let's see if I can do this. So 11x plus 4. I forgot. Is equal to negative 3. And then negative 13 and y is at 15. So negative 13x plus y is equal to 15. Right? 15. Okay. All right. So now I have these are new equations, and I mean we'll call them equation A and B. Okay. So let's move off to the side. We'll call them equations A and B. We had equation 1, 2, and 3, and now we'll have equation A and B. Okay, so I'll denote this as A. What's going on here? There we go. A and B. All right, so what do I need to do to cancel out the y? Well, it looks like I need to multiply the bottom equation by negative 4, right? Because if I multiply this bottom equation by negative 4, this becomes a negative 4y, and it goes cancel. That's what I want. Okay, so I'm going to multiply, excuse me. So this is just equation A again, just to kind of keep consistent with what I did on the previous page. And then we're going to multiply the bottom one, so a negative 4 times equation B. But we didn't really. Let's put colons there, since I did that on the previous page. Okay, so we have a negative 4 times a b, times b. So negative 13 times a negative 4, that's going to be positive 52x. And this would be a negative 4y, and this is equal to a negative 60. So we can now do the arithmetic here. We just simply add these together. We end up with a 63x. My 4y's cancel, and that's equal to a negative 63. Well, this seems pretty easy. I end up with an x is equal to a negative 1. That is the value of my x. Okay, so now I got the value of my x. I need to plug it into one of my 2 equations up here. Okay, so let's just draw an arrow up here into one of these 2. Now, the thing is, it doesn't so much matter which one you choose, but I like to choose the one where I have to do the least amount of computation. And so, in this particular case, I'm gonna put it into my equation B. Okay, so let's see, how can I let's do it this way. Let's do it up here, and then out here we're going to go. We're going to plug it into equation B, so we're going to have a negative 13x, so negative 13 times a negative 1, because that's what my x value is, right? Let's go put that in green, actually. Negative 1 plus y is equal to 15. Well, negative 13 times a negative 1, that is a positive 13. And if I subtract 13 from both sides, I end up with a y is equal to 2. That's my second one. Right? And now I have my x and y value, and I can plug it into one of my original 3 values here. And again, I'm going to pick the one that's pretty easiest to compute. Pick the one that's pretty easiest to compute. I'm looking here. Which one of these looks like the easiest? It looks like the 332. It looks like equation 2. So I'm going to plug it into equation 2. So it's 332 negative 3. It's 332 negative 3. So we're going to have a 3 times x, which is a negative 1, plus 3 times y, which is a change this. I always try to remain consistent. And then we have a 3 times a y, which is a positive 2. And then I think it's a negative 2 is the last one, right? Oh, no, it's positive. Okay, good. And it's a negative 3 at the end. So, and then plus 3z that's equal to a negative 2. Okay. And the arithmetic here, well, 3 times a negative 1, that's a negative 3. Plus 3 times 2, which is 6. Plus 3z is equal to a negative 2. And then the negative 3 and positive 6, that turns to a positive 3. And then if I subtract 3 from both sides, I get a negative 5 over here. Okay, that doesn't matter. We should have got whole numbers. Where did I mess up here? 3 and 1 plus 2. Oh, it's supposed to be a 2. Sorry about that. So this would be 2z. Right. And this is supposed to be a 3. Why? Okay, so I end up having those numbers backwards. That's unfortunate. So this was a 2, negative 3. 2, negative 3. 2z, negative 3. Okay, so there we go. All right, so again, let's recap here. The 6 and a negative 3, that is a positive 3. And if I subtract 3 from both sides, I end up with a 2z is equal to a negative 6. And if I solve, I would divide both sides by z, I get z is equal to a negative 3. Okay, so those are my values, the solutions to my equation. Of course, we can go back and check them like we did in example 1, but that can be an exercise for you. But anyways, that's how we do a system of linear equations. And the last thing is what happens when we have let's see, an unknown, not an unknown, but a blank. Holy cow, is that still the same example? That is, okay, yeah, so that's example 2. The textbook, I guess, goes a lot more in detail. I guess, I don't know, I mean, I went back and did everything. And what am I missing here? Oh, there, I was wondering, yeah, okay, so example 3 is down here. Yeah, sorry about that. I didn't see the example 3 down, so I guess I should scroll down a little bit further. Okay, so example 3 is much the same, except this time what we're going to do is we see that we don't have a value for y there, right? Well, that makes it pretty easy. That means that I don't have to I can essentially skip the first step I did on the example 2. Where I can essentially skip the first step where I got rid of a z, right? Because in example 3, well, one of my equations don't even have a y. So the natural thing here is to say, okay, well, my equation with 2 variables is, one of them is just going to be this equation 1, and the second one's going to be from equation 2 and 3. So we'll do, looks like if we're trying to get rid of the y, it looks like we're going to multiply the top one by negative 2. So we're going to say negative 2 times equation 2. Okay, so that's going to be a negative 2x minus 2y minus 4z, and then minus 34. Oh, I'm sorry, is equal to a negative 34. Okay. And then the second equation, well, I mean, we don't have to change that at all, right? We can just simply write equation 3, and that is just going to be an x plus 2y. Oh, this is nice, I guess. Oh, no, it's not. Plus z, I thought we were going to cancel out 2 of these, is equal to 16. We do the arithmetic here. We get a negative x. My y's cancel. That's exactly what I'm looking for. I have a negative 3z, and then we have negative 18. Okay. So now I've got my equation in 2 variables. And I'm gonna combine it with my equation 2 variables up here. Okay. So that makes it pretty darn easy. And then from there, it's just the exact same procedure that we saw for example 2. And that was a pretty short lecture. It's pretty easy once you do it. Once you get into it, it is kind of tedious, but I got nothing. That's really it. That concludes today's lecture.